Beam effective depth. What is beam effective depth? What are the factors to be considered when calculating the beam effective depth? What are the special things you need to consider? Work examples will be discussed today. Please subscribe our YouTube channel. You may get the notification on videos. What is effective depth? Effective depth is the depth to center of the reinforcement bars in the tension phase. This is mostly used in the structural design. During construction, you have to maintain that depth as it is in the as is specified in the drawings. You maintain this effective depth by different ways. You maintain the cover to the reinforcement. You keep the gap between bars as specified in the drawings and as per the general norms in the construction. For example, we consider the midspan of the beam. In a midspan, in the top of the beam you have compression, in the bottom you have tension. When you have a tension, you can't use the concrete to carry that tensile stresses because concrete get cracked, then it cannot bear the tensile stresses. In such cases, we provide the reinforcement. The effective depth is the depth from the compression phase or the topmost fiber to centroid of the reinforcement bar. You can see here the compression stress block here that carry the stress or that carry the load by the compression, but concrete can't carry, then rebar will carry that. This depth is considered as the effective depth. It's very important in structural design. We can't avoid this in designs. Effective depth of a beam reinforcement. As we discussed, effective depth is depth to the tension reinforcement bar from the compression fiber, topmost compression fiber. When there are several layers, effective depth for each bar could be considered individually or resultant point shall be considered. When you have several layers, here only you have 3 bars, only single layer. There may be several layers in a deep beam. So we have to consider the relevant effective depth in such cases. We'll see how to calculate this in next step. How to calculate? Let me introduce some figures, some parameters you need when calculating the effective depth. This is the depth we call effective depth. That's what we are going to find. Now, this height, that concrete surface to stirrup height is called the cover to the reinforcement. A is called the stirrup diameter. B is called the concrete bar, reinforcement bar diameter. This point to this height is the beam height. This is called H. So effective depth can be calculated from this equation. D is effective depth equals H beam height minus cover minus length diameter A minus B by 2 because the bar diameter divided by 2 because we consider it to mid height of the mid depth of mid or the center of the reinforcement. When we have given the following parameters, so in the design you can find these values. Cover strap diameter the bar diameter then you can calculate the effective depth when you know the height of the beam. So when these parameters are known, effective depth can be calculated as 500 minus 330 minus 10 minus 20 by 2, that is 450. So it's not that difficult thing to calculate the effective depth. So from this point to this point you can easily calculate. What happens if you have several layers? For example, you have 4 numbers to 20 bars here, 4 numbers of 25 millimeter bars there. Then the effective depth can be considered as the mid height of these two. So mid height here, gap between this center, actually the center between these two bars it's a mid height here. But when the diameters vary, this effective depth may be vary. For example, say you have 25 bars here, This layer you have a 16 or 20 bars. So depth will be moved towards this way. So you have to consider the geometric center or the area center when you consider the effective depth when the bar diameter is varying. So with that you can calculate the effective depth different occasions. So today we discuss about method of calculating the effective depth of beam reinforcement. What are the factors to be considered? We discuss about work example and the special things to be attended when you consider the effective depth of beams. Let's meet again from new video. Thank you very much.